Lesson for today is prefabricated timber framing system. Timber building is a lightweight structure where timber is used to build its main structural component such as columns, beams, floor, wall, roof, and trusses by using various types of joinery techniques. Prefabricated timber framing system is a timber building or module system manufactured in a form of pre-assembled building components with factory control environment in mass production either in factory or on-site workshop. The components are designed, cut and produced according to specification with standard shapes and dimensions transported and assembled on site. Anti-pest chemical usually applied for long-term protection. These photos show various examples of building using prefabricated timber framing system with various shape, dimension, and sizes. At the end of this session, students should be able to define timber building, identify timber building by its structural system, identify different types of building element, and able to explain its type, function, and construction method. Explain with appropriate sketches the constructions of timber building. Timber building is a lightweight building where timber is used to build its main structural components such as footings, columns and beams, floor, wall, roof, and other building elements by using various types of joinery techniques. Building construction studies for timber building are focused on connection method and composite material. Structural system is a main and the most important building element that actually makes the building stand. It functions as the skeleton for the building. There are two types of structural system for timber buildings. Number one, post and beam system or the local system, in which traditional timber house often use this system. Number two, frame wall system or load-bearing wall system. Prefabricated timber framing system is fall under this category. Post and beam system. This system is widely used locally, especially for traditional village house. This system consists of timber posts and beam as the main structural element. The system, also known as frame structure, as the posts and beams will be jointed together, forming a large frame and functioning to distribute load to the ground. Frame structure, in which the frame carries all loads while the enclosing and dividing wall elements being non-load bearing. This system consists essentially of pairs of columns with members spanning between them, spaced apart to enclose the volume of the building. The wall is therefore relatively light and thin, may be placed outside or inside the frame, or may fit into panels of frame. This system also called the post and beam construction. The post is an upright component of the timber frame. In other words, it is vertical. In a post and beam building, there are at least 4 posts, one at each corner, and often there are several more. Just as the vertical orientation of the post makes it a post, the horizontal orientation of the beam is what makes it a beam. Posts are vertical and beams are horizontal. Post and beam construction is a framework based solely on vertical and horizontal beams. Post and beam structures are constructed in layers, with each floor built independently from the others. Metal brackets are used to connect the beams together. This is an overview photo of a post and beam timber construction. The columns, beams, and roof trusses are all used timber components. The properties of the post and beam systems are: number one, the size of the structural members are normally big, such as 100 by 100 mm to 150 by 150 mm, and the numbers of structural members are less. The jointing method of structural members must be strong, tight, accurate, and firm to assure the stability of the buildings. Structural members are normally exposed and not covered or concealed. There are many types of timber connection methods. Number one, traditional method, which use 100% timber joinery. Number two, modern method, which use combination of nail, steel plate, steel bracket, bolt and nut, metal strap, and etc. These photos show several examples of the modern connection method using nails, screws, and plate. While these photos shows several examples of the modern connection using bolts and nuts. And these photos show an example of the modern connection using steel bracket tightened with bolt. Connections. Beams and columns connection are made with nails, bolts and timber connectors, dowels and cleats according to the type of members, whereas beam-to-beam connections are made by means of metal hanger or by metal cleats bolted or screwed to the beams. Rafter and joists may be supported by hangers or timber fillet. These photos show several examples of beam-to-column connection. While these photos show several examples of beam-to-beam connection. Column-base connection. Freestanding external columns are raised off the ground by means of concrete stool or block with a damp-proof layer between the timber and concrete. The column being fixed in position by a steel dowel or by straps and bolts. External perimeter columns normally bear on a continuous timber sill plate which is bolted to the concrete floor slab or perimeter dwarf wall which also carries the infilling wall panels. Internal perimeter columns usually bear directly on the floor slab, thickened to form a base if necessary, and are secured in position by a metal dowel. The advantages of timber frame structure. Number one, timber frame structure allows for larger openings to be built, such as windows and doors. Number two, allows for flexibility in plant and building operations. Number 3. Reduction of dead weight due to less weight compared to concrete and steel. Number 4. Although inferior to concrete and steel, timber can be very strong material depending on type of timber used. Number 5. Certain type of category of timber can provide good fire resistance. Number 6. Short construction time due to dry construction method and does not require curing time such as concrete. However, timber also has disadvantages such as number 1. Timber cost is now getting higher and more expensive. Number 2. Susceptible to rot due to exposure to extreme weather and climate. Similar to the concept of load-bearing wall, timber frame wall is a solid or load-bearing wall structure. The wall acts as both enclosing and supporting elements. The wall functions as partition and at the same time has the ability to carry load. And all loads carried are transferred to the ground through the timber frame wall. However, a wall can be thick due to nature of walling materials. Timber wall frame may be constructed by framing together relatively small timbers at close interval so that a wall or partition panel forms a load-bearing system. Timber frame wall is a form of frame structure but without columns and beams acting as primary load-bearing members. The wall itself functions as load-bearing because there are no columns and beams. The term frame wall is usually applied to an external timber wall involving in its construction appropriate cladding and insulation. Timber construction of timber frame wall is very common in foreign countries such as US, Canada, and UK. But how is the timber construction potential in local? Here in Malaysia, durability, credibility normally carry by concrete and steel. Perhaps this is due to the extreme weather and climate that could damage timber easily over time. Timber frame wall consists of several components. Number 1. Vertical members or studs. Frame between horizontal members of same section at top and bottom. Space at 400 mm centers, same as timber floor joist. Number 2. Horizontal members such as top head plate and sole plate or piece. Number 3. Joints. Simple butt and nail joint such as frame is non-rigid, therefore require bracing. Number 4. Diagonal braces or plywood external sheeting. This is to stiffen the structure. For timber frame wall, the size of the structure members are small, such as 100 mm by 50 mm or 100 mm by 75 mm. The numbers of structure members are big compared to post and beam system. The joining method are simple, such as nail. The structure members are normally encased in the wall or hidden. The timber frame wall component consists of number 1. Studs, which is the vertical members. Number 2. Head plate, which is the horizontal member. Number 3. Sole plate, which is also the horizontal member. The size of the structure members are uniform, such as 50 mm by 100 mm or 75 mm by 100 mm. Again, the photos show the detailed components of timber frame wall. This is the basic components of timber frame wall. Consists of a head plate at the top, sole plate at the bottom, and start at 600 center to center. There are two ways to construct a frame wall timber building. The frame wall building can either be constructed by number 1, on-site or in situ constructions. Number 2, prefabricated at factory and erected at site such as wall frame and floor frame. Timber structure must be raised off the ground by erecting it on a base wall or foundation beam with dam-proof course or DPC level. Wall plate is set and level on DPC and the plate is then securely anchored to foundation by bolts. Insulation can be installed within the prefabricated timber framing system and covered with membrane or plasterboard. The advantages of timber frame wall are: number 1, lightweight and easy to handle. Number 2, can be insulated to provide thermal comfort. However, timber frame wall also has disadvantages. Number 1, longer construction period compared to post and beam construction due to complexity of the construction process. Number 2, requires skilled labor to construct. And number 3, less fire resistance and require fire stopper. As you can see in the table, this is the different characteristics between frame structure and frame wall. Prefabricated timber framing system can be divided into three categories. Number 1, modular construction system. Number 2, panelized construction system. And number 3, pre-cut system. At the end of the session, students are able to: number 1, define the prefabricated building system. Number 2, identify various types of prefabricated building system and differentiate them. Number 3, explain the advantages and disadvantages of prefabricated building system. Prefabrication is assembling components of a structure in a factory or other manufacturing site and transporting the assemblies or sub-assemblies to the actual site where the structure is located. Final assembly will be carried out at site. Prefabricated versus conventional. In conventional method, construction materials are brought into construction site and are used to construct the building. Whereas in prefabricated construction, only the foundation are constructed conventionally, while other components are prefabricated in factories then transported when arrived, lifted by crane for assembly. Prefabricated timber framing system is part of industrialized building system or IBS. It is a timber building or module system that manufactured in a form of pre-assembled building component with a factory controlled environment in a mass production either in factory or on-site workshop. The components will be designed, cut, and produced according to specification with standard shapes and dimensions or size changeable, transported, assembled on site. For protection, anti-pest chemical usually applied as a first finishing layer. Normally, timber framing system is for roof trusses and structural framing system such as wall and floor. This is probably because other main structures such as column and beam may require obvious different sizes for each different buildings depend on the total load that need to be supported. Under prefabricated timber framing system, there are three categories. Number 1, modular system. Number 2, panelized system. And number 3, precast system. Modular design or modularity in design is an approach that subdivides a system into smaller parts or modules that can be independently created and then used in different systems to drive multiple functionalities. Whereas for modular construction, building will be subdivided into modules such as generic sections or part of building assembled in factories that can be used to build various types or shapes or sizes of building. Modular system. It is a dimension and space coordination concept in which building and components are placed at their designated base. Modular homes or buildings are factory built and did not rest on a steel chassis. Modular homes are assembled on a fixed foundation. Cost of construction is less to construct than stick-built homes or buildings, often used for emergency construction such as after disasters. Constructed in accordance with the International Building Code. Modular buildings and also modular homes generally consist of universal parts or modules that are manufactured in a factory and then shipped to a build site where they are assembled into a variety of arrangements. This gives reduction in cost due to lesser customization and less learning time. These are the several examples building using prefabricated timber framing system. The building looks identical and repetitive in design. This is the example of the installation process of a building using modular system of prefabricated timber framing system. The building is lifted using crane and placed onto the already constructed strip foundation. Next is the panelized system. So in this system, there is no pre-assembly creating a three-dimensional arrangement as in the modular system. Panelized systems require more labor-intensive on the construction site. It also provides a degree of design flexibility even in standard sizes. Panels are usually produced in sizes that suit certain building styles and configuration. The panels themselves fall into classification of open or closed. Number 1, open panels refer to factory assembled wall, floor or roof panels that are open on one or both sides to facilitate construction and installation and regulatory inspections of mechanical, electrical, and plumbing services. Number 2, closed panels are enclosed on both sides. During construction, open panel timber frame is covered internally by plasterboard, filled with high-performance insulation and moisture or vapor barrier incorporated. The construction process of internal wall. Internal wall construction is similar to external wall construction. We start at either 400 mm or 600 mm center to center. Horizontal beams or noggin fixed to prevent lateral buckling. A damp-proof course should be provided to the undersides of all ground floor partition when sitting on concrete or block work. Internal partitions are usually lined with 12.5 mm plasterboard, fixed and skimmed. To prevent moisture entering into the plywood sheeting during construction, a braceable membrane is stapled onto the plywood on the external face. This membrane also provides a second line of defense should moisture penetrate the exterior cladding. Next is the pre-cut system. Pre-engineered or pre-cut systems are the least prefabricated. It is the most expensive type of factory-built system, which require the most on-site precision pre-cut components work. The components fit together like jigsaw pieces. They come in a variety of types including post and beam construction, log homes, frame buildings, and geodesic domes. Normally, pre-cut components are bundled in system lots for sale. They are the simplest type to ship and often there is little wasted material. This is the example of constructions of pre-cut timber post and beam house. The photos show the process of cutting according to the dimension. These photos show the preparation works of components to be transported and delivered to construction site. As you can see in the photos, cranes were used to lift and position components for assembly. The components were positioned according to the layout. The photo show the assembly process of the components. These photos show the connections of the components. Finally, the pre-cut components were already installed. After that, the installation of wall cladding to the pre-cut components. The prefabricated timber has three components. Number 1, beam. Number 2, columns. And number 3, roof trusses. This is the example of constructions of the panelized system from foundation to the installations of columns and beams. The process continues with the installation of roof trusses until completion. Foundation for light framing are made in most cases of side cast concrete or concrete block masonry. Concrete and masonry foundations are highly conductive of heat and usually must be insulated. Good foundation is easily insulated in the same manner as the frame of the building it supports. A platform is built. Walls are assembled horizontally on the platform and tilted up into place, and another platform or a roof is built on top of the walls. Work is accomplished without the use of ladders or scaffolding, and temporary bracing is needed only to support the walls until the next level of framing is installed. The seal, preferably preservative-treated or naturally decay-resistant wood, is bolted to the foundation as a base for the wood framing. A single seal is all that is required, but in better quality work, the seal is often double for greater stiffness. The top of the foundation is usually somewhat uneven, so at low spots the seal must be shimmed with wood shingle wedges to be able to transfer loads from the frame to the foundations. A compressible fibrous seal sealer should be inserted between the seal and the foundation to reduce air infiltration through the gap. The normal foundation bolts are sufficient to hold most buildings on their foundation, but tall frames in areas subjected to high winds or earthquakes may require more elaborate attachment. Bridging, which is cross-bracing or solid blocking between joists at midspan, is a traditional feature of floor framing. Its function is to hold the joists straight and to help them share concentrated loads. It should be used on better quality buildings because it makes a noticeable difference in the rigidity of a floor. Some building codes require blocking to be installed at the mid-height of the studs in wall frames that are taller than 2.5 meters. The purpose of this blocking is to stop off the cavities between studs to restrict the spread of fire. In roof framing, the pitch is specified as a ratio of rise to run. Meanwhile, rise is the vertical dimension and run is the horizontal. Truss rafters are used on most timber frame houses. Roof trusses and floor trusses find widespread use in platform frame buildings because of their speed of erection, economy of material usage, and long span. Most are light enough to be lifted and installed by two carpenters. Manufactured wall panels have been adapted more slowly than roof and floor trusses, except by large builders who mass market hundreds or thousands of homes per year. What are the advantages of using timber prefabricated system in building construction? Advantages of prefabrications. Number 1. Less false work such as formwork, shuttering, and scaffolding needed on construction site. Number 2. Construction time is reduced, thus possible earlier returns of the capital invested. Number 3. Minimization of on-site construction and congestion. And number 4. Better quality control in factory. Prefabrication can be located where skilled labor is more readily available and cost of labor, power, material, space, and overhead can be lowered. Minimization of time spent in bad weather or hazardous environment at the construction site. Less wastage due to precision cutting. Easy adaptations of advanced materials or construction technique. Timber framing system incredibly quick construction times, promoting greater efficiency, speeding up project durations. The panels are manufactured in a factory environment under strict quality practices and engineering terms. Can incorporate a large variety of exterior finishes. The versatility of wood can give great scope for architectural and engineering design. It lends itself well to prefabrication and mass production, thus less wastage. Wood is highly effective insulating material. The average fuel maintenance cost of a timber frame home is approximately 40% less than for masonry buildings. Timber frame is a dry form of construction which avoids the long drying out period associated with wet construction. Wood is an ecologically friendly and renewable resource. Using it reduces the effect of global warming. The manufacture of wood products uses less energy than the manufacture of other man-made products. The disadvantages. Number 1. Careful handling of prefabricated components is required. Number 2. Attention has to be paid to the strength and the detail of the joining method to avoid failure. Number 3. Leaks can form at joints. Number 4. Transportation costs may be higher. Number 5. Large prefabricated sections require heavy-duty cranes and precision measurements and handling to place in positions. Number 6. Larger groups of buildings from the same type of prefabricated elements tend to look drab and monotonous. Number 7. Poor prevention of capillary movement of water within any exposed timber, leading to eventual creeping and warping. Number 8. Poor acoustic insulation, footsteps and movement in adjacent rooms easily heard. Number 9. Decisions of units and shaft location must be made in design stage in order for placement of studs. Number 10. Wood-boring insects and pests commonly present in wood frames. And number 11. All wood will eventually rot. The building regulations require that timber cladding should be made from durable species or treated with suitable preservatives. They also require that all timber which occurs below dam-proof cost or DPC level must be treated against insect and fungal attack. Other timbers do not require to be treated with preservative, but most manufacturers do treat all their timbers. Approval for fire and the structural stability of timber frame houses require a certificate of approval by a structural engineer or another equally approved organization before erection. That's all for the lesson this time, and thank you very much.